Have you ever wondered if the very tools we build to make us smarter might actually be making us less aware, or that the most advanced artificial intelligence systems are struggling with the same fundamental question as the human brain? How do we truly integrate information to create meaning? Today, we are diving into a groundbreaking shift in science that challenges everything we thought we knew about learning, consciousness, and the architecture of intelligence. We will explore why simply copying experts or averaging data can lead us astray, and how a new wave of empirical testing is finally revealing the true mechanics of how minds, both biological and digital, actually work. Stay until the end because the results we uncover today suggest that the future of AI and our understanding of consciousness depends not on building bigger models, but on refining how we verify and reward the information within them. For decades, the dominant narrative in both artificial intelligence and cognitive neuroscience has been one of expansion and accumulation. In the world of AI, the goal has often been to build massive monolithic systems that see a Chinese letter swallow vast amounts of data, assuming that more connection equals more intelligence. Similarly, in the study of the human mind, philosophers and scientists have debated whether consciousness is a global broadcast signal flashing across the entire brain or something more localized and specific. The prevailing assumption in machine learning has been that if we take the best solutions from expert teachers and distill them into a student model, performance should naturally improve. We have operated under the belief that averaging opinions or merging outputs creates a robust, reliable truth. However, this research suggests that these standard approaches may have a critical flaw. They might be silently suppressing the most important signals while amplifying the noise, leading us to build systems that are wide but shallow, connected but not truly integrated. Recent studies have turned this tide by subjecting our favorite theories to rigorous, adversarial testing, and the results are nothing short of revolutionary. In the realm of machine learning, researchers discovered that the standard method of averaging probabilities often drowns out the unique contributions of high-dimensional experts. By introducing a new metric called sum-abs-shap, which weighs the absolute value of influence rather just the average, scientists found that they could restore the voice of these experts in complex, cross-modal tasks. This simple shift in calculation led to a weighted F1 score of roughly 0.65, a significant leap forward that proves preserving the nuance of individual contributions is far more powerful than blurring them together. Even more startlingly, a major study on coding education revealed that the common practice of imitation-based fine-tuning, where students are trained to mimic the pooled outputs of top teachers, actually degraded performance. When students were forced to imitate these aggregated solutions, their accuracy dropped from nearly 6% to just under 3%. It turns out that trying to copy a consensus of experts can actively confuse the learner. In contrast, when these same verified solutions were used not as a template for imitation, but as a dynamic landscape of rewards in a reinforcement learning environment, performance soared by 49%. This suggests that intelligence is not about static copying. It is about dynamic interaction and verification. This pivot extends beyond code to the very nature of our own awareness. For years, the debate over consciousness has been split between two major theories: the global neuronal workspace, which views consciousness as a global broadcast igniting the prefrontal cortex, and the integrated information theory, which sees it as the result of integrated information processing. Through new empirical adversarial testing using advanced brain imaging, the scale has finally tipped. The data now strongly favors integrated information theory, pinpointing the posterior hot zone of the brain as the true neural substrate of phenomenal consciousness. This means that our conscious experience isn't necessarily a global announcement echoing through the whole brain, but rather a specific, localized synergy of information processing in the back of our minds. These findings collectively tell us that whether we are building AI or studying the human soul, the key lies not in the sheer volume of data or the breadth of connections, but in the quality of how that information is weighted, verified, and integrated. So, what does this mean for our future? For the developers shaping our digital world, This is a call to move away from static, one-size-fits-all architectures. It urges us to build AI systems that are attribution-aware, capable of recognizing and preserving the unique weight of every piece of information they process. For the scientists exploring the mind, it provides a concrete anatomical target, opening new doors for diagnosing and treating disorders of consciousness, from coma to anesthesia, by focusing on specific neural dynamics rather vague global states. Ultimately, this research teaches us that progress comes not from merely connecting more dots, but from understanding the quality of the lines that connect them. As we stand on the brink of this new era, let us commit to building technologies and understanding ourselves through frameworks that prioritize rigorous verification and dynamic learning over simple imitation. If you found these insights as thought-provoking as I did, please like this video, subscribe to the channel, and comment below with your thoughts on whether you think AI will ever truly replicate the nuance of the human mind. Stay tuned for our next episode, where we will explore how these new theories of consciousness might reshape the way we design education for the next generation.